wrote up a cool problem for the lecture today. I forgot to take a picture of it. Oh, I think we're gonna be all right. Cool. All right, friends, so next little unit that we're doing here is on applications of the integral. We're gonna do a number of cool things that you can do with an integral, different ways to look at it. And once you see an application of something, it gives you a different way to actually view that thing. So, all sorts of good stuff going on here. Applications. I'm just gonna do one today, nice chill one. There's a very short web work that's 5 problems long. And after I get done talking about this, we'll take some time to work on that. And then hopefully knock it out, because on Friday I want to start actually the next thing. So just a small application today. The area between curves. This is pretty easy. It just requires a little extra algebra that we haven't really done a lot of yet in here, but we'll get some good practice. So visualizing things and finding intersections of things are going to be key skills here. Let's just start off with the basics. So the problem is this. Problem. Find the area between 2 curves. And there's actually a couple ways this can manifest. One, so 2 basic forms that we have here. The first one is I've got a problem like this. I've got a function y equals f of x, and another function y equals g of x. One's clearly above the other. And that clearly, I'm putting it clearly in per quotes, because that's not always clear. But in this picture, it definitely is. And then we've got a range of x values, so x is going to run from A to B. And what I'm really interested in is that area right there. Well, let's think about some things we already know. This area right here is going to be the difference of 2 areas. So first off, it's going to equal the area under f all the way down to the x-axis. So if I just take y equals f of x, let's call that a1. That's just the integral of f of x dx. That's how we literally defined it at the beginning of the semester. So it's this big area, and then I just subtract off this little one. So minus, let's put even equals here, minus, and let's see if I can get a decent version of that little weirdo curve. And then this is A to B, this is A to B, so we take that area right there. This idea of taking something and subtracting off something else is going to be key for the next week, pretty much. So this is A2, and so we're going to subtract off integral A to B, g of x dx. And the fast way to do this, you wouldn't write this as 2 separate integrals. You would just simply write this as top curve minus bottom curve. Look at how I said that. So let's write this in a mnemonic way. The integral from start to finish of top curve minus bottom curve. That's going to be key here and in a few days, like Friday. So this is one kind of problem we're going to deal with. The second kind is going to be one like this, where I don't have an x range. So like this would be given. You let x be 2 to 5 or something like that. Another one is where I've got something like this going on. This is way more interesting. So let's say this is y equals g of x here. This is y equals f of x. And I'm interested in the bounded area. In a couple of weeks, we'll be able to do unbounded areas. And that'll actually be, that's really cool and exciting. But this region right here, what I need to do is, one, find the intersection points. So I really have to create my own limits for the x values here. So this is x, I have to find that intersection there, and I have to find that intersection there, A and B. And then 2, determine which curve is on top. And that's probably a problem here, but I think it becomes more manifest here. Determine which curve is on top. That's like Desmos time, or you actually know how to graph stuff, which is even better. So get a graph. And then 3, same procedure, it's just going to be the integral from A to B of the top curve minus the bottom curve, dx. If I had a couple regions up there, the top and the bottom might change. So let's just make a little note here. What's the top curve might change? What's top and bottom might change? So we have to be wary of that. That's where step 2 gets really helpful. And I mean, it might change like in process as I'm moving from left to right. So that's where things get fun. Let me give you a second to get caught up on all that stuff down. All right, so let's get into this. And like one of my favorite ones. So we'll just do some problems together and then I'll set you loose. Find the area between, and I'm going to put bounded area here. So I'm actually starting with the harder one. Between y equals x squared and y equals x to the 1/2, square root of x. So a function and its inverse. Step 1, get a graph to understand what is happening. So this is a parabola, y equals x squared. Hopefully that makes perfect sense. Let's actually do it over here. And then I've got y equals the square root of x. What's the domain of that? So if I have this function, square root of x, what do I have to be worried about?
Some graphing.
So what's that? Yeah, I see.
The negative inputs.
Yeah, it can't have a negative input, right? So this is defined only, so the domain is x has to be greater than or equal to 0. So nothing's going to be over here. This is n inverse of x squared. It's not the only one, but it is n inverse. And it looks like that. Oops, not so much. Because it's really just the reflection of y equals x squared over the diagonal. So it's quite pretty. It makes that little fish thing going on there. And then I have to find the intersections. So you could probably do this by inspection. One's real easy, right? 0. They both, when x equals 0 in both those, y equals 0. We can also see that when x equals 1, y equals 1 in both. Do you just make sure you can kind of verify that you see that 1, 1 is a point on both those graphs? Does that make sense? And if not, let's prove it. So, how would I find these 2 points? If it wasn't obvious, so I would look at the graph, you probably go there and you go like, oh, it looks like 1. Just plug that point in and make sure that you get 1, 1 for both of them. But to find the intersections, and here's where I think some challenge is going to come in for a lot of folks, because it requires you to remember your algebra skills. To find intersections of y equals f of x and y equals g of x, set the 2 functions equal to each other and solve. So here, and it doesn't matter who's f and who's g. It looked like it, but really the whole key is top minus bottom. That's the only time we have to worry about discriminating between these 2. So here I'm going to set x squared equal to x to the 1/2. I got to solve that. Any suggestions? Tips?
Square both sides.
Square both sides sounds like a great move. Get rid of that dang square root, right? Why not? So you got to be careful when you square things. Sometimes you will introduce extra solutions. I'm just gonna square both sides, like Scotty said, like that. Next moves. Let's be careful with that. So wait, who said that? Is it Voin? Yeah, so that'll work, but we have to be careful, Voin, because what can happen is when you divide out, you throw away solutions. So I would only divide by x if I said, first off, notice that x equals 0 works here. Then I can say x is not 0 and divide by x. Yeah, Sophie?
Don't you have to set it equal to 0?
That's what I would do. So like, I think that's like a better, just safer route. Nothing wrong with what you said, Voin, just gotta be careful. So I would get everything to one side, get a 0 on the other. The idea is to get a product of things over here. And so let's see, so then factor as best you can. If we wanted, we could factor that a little bit more. That factors as x times x minus 1 times x squared plus x plus 1 equals 0. Or I could just leave this unfactored. Either way, it's gonna work out okay. Why do I get a factor? Why do I factor and have it equal to 0? So if you have a product of things that like this, you got this, times this, and maybe this list goes on equals 0. So given this, one of these things has to be 0. The only way you can multiply numbers together and get 0 is if one of them is 0. So this means one of these things must equal 0. So we set them each equal to 0. So you actually get 3 smaller problems. So you set that equal to 0, set that equal to 0. You set whatever the hell that shit is equal to 0. Big splat. So got this guy down here. And now we're gonna do what I just recommended. I'm gonna set each piece equal to 0. So I've got an x equals 0. Or, so I'm gonna so here. Or x minus 1 equals 0. Or that piece actually can't equal 0 here. So you would have to see, this has only got complex roots. If you got the quadratic formula out, you'd see that this has imaginary roots. So I'll put that here. If you sketched out the graph of this, it would look like a parabola with a vertex like this. It would kind of look like this. So the graph of this is this thing. It never hits the x-axis, so it's never 0. So this piece here can never equal 0. But if you didn't see that, let me come back. I could have stopped right here, because this looks pretty chill. X equals 0, so, or could have stopped earlier. And notice I just pointing all these things out for you so you realize you have options. Earlier, and said, well, x equals 0, or x cubed minus 1 equals 0. And this one, you'd probably like get the 1 to the other side, and then take the cube root, and there's nothing wrong with that. You see you get the same thing up there. So either way, x equals 0 or x equals 1, and we proved what I drew like 20 minutes ago, basically. So gain your intuition. Check yourself. If you're not sure, you gotta go this slightly more painful route. All right, so we're almost done. Now we gotta still set up the integral. So let's see. So that was and solve. So now our answer is the area is going to equal the integral from the start to the finish of the top curve. Notice the top curve is square root of x. And the bottom is x squared in that little fish shape there. And then we just crank that out and we're good to go. But I kind of want to crank it out because I'm curious. I'm curious as to what that might be. So we're going to do that. That goes to 3/2, so we get a 2/3 out in front. That goes to 1/3 of x cubed from 0 to 1. When you plug in the 0, everything dies. When you plug in the 1, you get 2/3 minus 1/3. Yay. Cool. That's pretty. Who would have thought? Who would have thought? I would have thought. All right, that's the game. Let's practice. I've got a bunch for us. So I did bring a printout of someone's web work. So I've got all sorts of web work for us to go with. Let's do one more together. Maybe a couple more. How about this one? So please, first of all, I guess I should add what kind of this like cruising here. Any questions on any of this so far? Pretty straightforward, right? So, oh yeah, Lloyd.
So we just do like the absolute value and not worry about which one is the top and which one is the bottom.
You can, but to actually, so like, if I were to give you an integral like this, this in here, and I asked you to do that, to evaluate this absolute value under the integral, you still have to actually remove the absolute values at some point. So this thing, like right here, let's say I had two functions and they went like this. So here's f, and then here's g, and I asked you to do that from a to b. And I said, oh, take the absolute value. How am I gonna work that inside here? I'm still gonna have to figure out, the absolute value is still gonna be top minus bottom inside here. So for this one, I would have to break it into two separate integrals. I'd have to figure out what that point is, because notice that f is on top there, but f is underneath there.
But what if we did the absolute value of the integral from a to c and then from c to b?
So
The
how, so
absolute
just
value is on the outside, not inside the integral.
like this?
Yeah.
Oh, yeah, that would probably work. Yeah, but I'd like you to think about it a little deeper. But you're right, yeah. So like when you're in a survival situation, the wolves are coming to your camp, and you got to solve this integral fast. Your way works. But I want us to understand this. But you got a good idea there. So here's a little tip. What Voin said: if you get a negative answer, you've got the wrong top and bottom. Make it plus. So do basically. So I guess I'm basically saying do what Voin said. But I want you to know that you got it backwards. That's all. So good point. All right. So let's take a look here. What do I got? All right. Oh shit. Well, I was very ambitious with these. So okay, so we got y equals x squared minus 2 and y equals 1/2 x plus 3. Can you first sketch that region for me, please? Parabola one's a line, so not too crazy. I'm not trying to shut the show down right away. I can create another problem. I'm working on that. Go ahead and knock the area out if you want. You're going to have to find intersections, figure out where those are. something like this, got a parabola with a slanted top on it. See if we can find those places where it intersects, setting those two curves equal and solving. Got some questions.
Just didn't know about the root.
Oh, so how did I get those roots too? Those are where this equals 0. So when, so see here, so when x squared equals 2, that's when I get y equals 0 for that one.
Okay.
That's, yeah, to add that little detail. Won't matter in what we're doing, but nice to know. Does that help?
Yeah.
Cool. Now, I don't know if this is gonna turn out pretty. It might not. It's looking kinda grim. Yeah, looks grim. How do I do something like that if I can't figure out how to factor it? Quadratic formula.
I don't think I even remember the quadratic.
Well, let's
formula.
put it up here.
Plus minus 4ac.
Oh, yes, I hear it.
I read that part.
Babbling up like a brook, making sounds, all these. You'll want that. That isn't bad. Let's try that together. Still gonna be weird. It's okay, we can handle this. We've prepared ourselves emotionally for 3 to 4 weeks. That is fugly. You're gonna make up a problem. You're gonna be dealing with problems. So let's see here. So we got 1/2 plus minus. What is that? 81/4. Hey! No. Yes? You gotta be fucking kidding me. Wait, is that right? Well done. Well done, sir. So let's see, so we got 1/2, times 1/2 plus or minus 9/2. Holy shit. Unfucking believable that that works. So that is 1/4 plus or minus 9/4. And so that is, let's do the minus part first. So negative 8/4 and then 10/4. Have thought. So we've got negative 2 and 5/2. Let's stick it there. Not bad. Not bad at all. And let's just get this integral set up. Let's not do this integral. Because we know how to do integrals. Or at least I'll find out if we do as soon as I get those tests graded. I got a feeling we know how to do integrals. So this area A, and a lot of times I will, like, I'm not sure what the next exam will be. Next exam could possibly be like a take-home kind of thing too. So we'll see. Integral, what am I doing? Integral from the lesser to the greater of the top. So here I'm gonna put 1/2 x plus 3. I'll just put it in parentheses to be safe. Definitely gonna put this one in parentheses to be safe. Really common error is to forget the parentheses. And you can see what a mess that would be. Equals the area. I'll just leave it at that. Let me know if that sounds okay.
Will you specify when you want like an actual number?
Yeah.
Okay.
Like web work.
Okay.
Like WebWork will want an actual number on your 5 problems. I wanna do one more to cut you loose. It's the one I just made up, but it's good. It's pretty sweet. So please find the area, the bounded area between these two curves. See, the key word is bounded. That word bounded is important because there's other areas between these two curves. I want the one that's finite, that's clearly finite, that you could draw a circle around. That's what bounded means. Bounded literally means you could put a box around it or a circle around it, a finite radius or finite side length. All right, so find the bounded, that's my BDD is bounded, area between y equals 2x squared plus 5x plus 3 and y equals x squared plus 6x plus 5. Both parabola. Wait, that can't possibly be. No, I guess it is. Yep, let's just do it. Yeah, it's what the math says here. Couldn't possibly be wrong. I'll start sketching for us. That'd probably be helpful. Show you some tricks on sketching parabolas too while we're at it. Yeah. I'm just getting these hyperbolas into what's called canonical form, which looks like this. And then once you have them in this form, you can complete the square. You can see that the vertex is at HK. It's really a useful thing to just, if you don't have a calculator around or you want to, have a deeper understanding of things. And then if A is positive, it opens up. If A is negative, it opens down. So it's A positive right here. So that's what I did for this one, and I can see where the vertex is at -5/4 and -2/16, -1/8. I'm going to do the same thing on the other one, which actually factors nicely, right? That second one is x plus 5, x plus 1. Yes?
Where did the 25/16 and the -50/16 come from?
Or the 3.
Well, I know there's
So-
a 3, I know where that's.
So the three
That just came down.
The 3 just came down. So what I did was, so I'll go through that. It was a little fast. I want a perfect square here, right? And so far, this is just the original, just with that 2 factored out. So think about how a perfect square works. I want to take, this number here should be the sum of the 2 numbers. So like, I'm gonna have x plus, this thing must look like that to get that 5/2 for the O and the I for the FOIL. Does that make sense? So, and then I think, okay, well, what would this last be? This would have to be a 25/16 here to make that. But I can't just throw numbers in. So what have I effectively added? I've tossed in a 2 times 25/16. So I'm going to subtract off 2 times 25/16 to maintain balance. So that's just 2 times this number right here, subtract it off. Okay. Does that help?
Yes.
Yeah, beautiful. Glad you asked. I was hoping somebody'd ask, so that works out good. It's a useful skill, that completing the square. This one, like I said, this is a parabola that opens up that goes through -5 and -1 on the x-axis, but let's play the game I just played. So I've got x squared plus 6x, and I'm gonna pull that 5 out this way. I'm gonna take half this number, which is 3. I'm gonna square it and add it on, so 3 squared. That makes this now this. But I have to subtract off the thing that I added on. So this becomes x plus 3 quantity squared minus 4. That one's pretty. So I've got two parabolas, both opening upward. This one's much steeper than the other one. So let's see what's going on here. I'm feeling like this weird sense of dread, and I'm not sure why. I shouldn't. I think it's gonna be okay. So let's see, so that one's at -5/4, this one's got a -3, -4. Let's set the scale for the craziest scale needed. When I was younger, and before we had things like Desmos, I fucking loved graphing things. That was like my great joy. I think it's one of the reasons I became a mathematician. Besides some other reasons I'll tell you later. Too long a story. So let's see, so -5/4 is here, and then -1/8 is like there. Gadzooks. And I don't know where that thing touches the x-axis. I don't want to know, but I do know that when x is 0, y is 3, that's my vertex. So I'm going to have super steepy thing like that. So that's the top one. And then this one here is a much mellower individual. So at -3, -4. And that guess goes like this. So where does this cross the y-axis? At 5? Oh, look at that. So that must go something like that. And so the bounded area must kind of be over here, is what I'm thinking. What a great graph. That's pretty nice. Does somebody have a graphing utility? Yeah, we got some laptops open here. Somebody Desmos this thing.
Crosses
Does it even look remotely like what I've got here? Kind of. I'll go for kind of. That's really my key. Oh yeah. Oh yeah. So it's kind of like in here that it. Oh, okay. Thanks. So actually, the area is over here. Yeah. So like the area is over here. So this goes like this, but then this one kind of comes up and beats this one eventually. It's kind of tiny. It's a tiny little wedge. So having a graphing utility, absolutely key on this kind of thing, unless you're given the graph or you want to spend much more time than I did graphing. But let's find these intersections. In the end, we don't even need this graph. Let's think about what we know. We need to find the intersection points. We're going to take top minus bottom. And like Boyne pointed out, if we get a negative, make it positive. It'll all be okay. We just fucking did it backwards. It's no big deal. It's not a big deal. So let's find the intersections. Can you do that for me? Really quick, without the graph. So let's find the intersections. We're going to set those two equal. Because this is pretty much what I engineered this for. So that this part would be easy. I clearly didn't engineer it for graphical ease.
into a -1, is that what you saw in there, Boyd?
Yeah.
All right.
So we should be getting x equals 2, x equals -1, and we just set it all up. Let's not compute it, but let's just get it set up. I think that I think the second one is on top there. Boy, would you mind just zooming in on your graph really quick? Is it the x squared plus 6x plus 5 that's on top in that intersection region? Yes? Okay, cool. So, we're gonna go x squared plus 6x plus 5 minus 2x squared plus 5x plus 3. And I would simplify this. I mean, you're welcome to integrate this and do the difference, but I think a much smarter, more efficient move is to subtract these things. And do that. You'll be a lot happier camper, right? It's just a lot less work and with a little overhead up front. That's the game, friends. Use graphing utilities on this web work. And let's roll on it. I think you're gonna need them right on the first one. If you're living the Luddite lifestyle, I don't know what you're gonna do for graphs, but
I'll pull it up.
you'll okay. I hate to ask this. Does anybody have any vegan food they can give me?
Vegan?
Yeah, I'm vegan,
Can't say
but I need.
Can't say that.
No. Damn. I'm so hungry. I didn't have time after my
I don't think
interrogation.
that's vegan. There's no way that's vegan.
Are you checking to see if
It's
that's
a
vegan?
protein bar. There's
I think I've got some like sweet tarts, which are probably not even vegan.
The bar looks vegan.
There's no way.
It looks vegan. Look, it's not, it all looks the way it's on.
Milk.
Oh, is there milk?
It says
Oh,
milk
I'm
right
blind.
there.
We're just gonna run down to that crappy machine, the bread bag. See if it takes my folded dollars. Right back.
Why are you provided with X values? Does anyone know? I get why we have like the two like y equals something to x, but like why are we being given X values?
Probably so.
Yeah, I don't know either.
Yeah, I'm sure we'll use it for.
Hey, Brandon. Oh, wait, they found those for you. Those are the intersection points.
Oh.
I think.
Oh, it is, okay, that's just easy points.
Yeah, that's really just.
Yeah. So we don't have to.
natural log is increasing function, so, yeah.
And then you plug in that there.
Yeah, top
Either
minus
X
5.
minus
Yeah, so
2x.
whichever one was on top. Which one was it, the 2x or the x?
It's hard to say what's on top, because I'd say it's probably e to the x,
Oh, okay,
I think.
so here, so your red one is the e to the x?
So yeah, that looks
Yeah.
on top. So are we finding there?
Well, wait, let's see.
I don't know, I can't tell if it's there or, yeah.
Well, what are your numbers? So they're natural log of 2, so it's actually over here.
So it wants this area.
Yeah, well, did they give you the bounds? They
Yeah.
must have.
Yeah.
Oh, okay, okay. So natural log of 2 is a positive number, so it's over here somewhere. So you just like, there's a little slice here. Here, watch, actually, let me show you. Type in there, type x equals natural log of 2. And then type x equals natural log of 4. There you go. So it's showing
So
you.
it's right there.
Mhm. Yeah, yeah.
Okay, makes sense.
So, if we aren't given the like bounds, do we assume it's like the enclosed red?
Yes. Yeah, yeah. If they don't give you an X range, you gotta do the extra mile.
Okay.
Yeah. Please, Scotty. Oh, I mean, I don't know. I don't think, put equals in front, first off, probably, 'cause I don't think this thing acts like a calculator. Does it?
Yeah.
That's, no, equals on the other side.
Over here?
Yeah. Try that.
Yeah.
Yeah, I've never used it as a calculator like that, so I don't know, click on that box, does that tell you?
Just gives me.
Yeah, then I was gonna say, I don't think it works as a calculator. So just,
Unfortunate.
yeah, just get a calculator out. Here. Like, here, no, look, give me your search window, I'll give you the better calculator. Do you have like the little search for like apps down, not that one, but like, yeah, like the start.
Up here maybe?
Oh, this is an Apple. Oh, yeah, shit, I don't know how to do anything on there. Type calc. Oh, let's try that. Try that calculator. And then go to, see, how do you get options on something on a Mac? And click up here on these buttons.
That's just closing.
Click on the plus.
Ah, thank you.
You're welcome. Much better, right? This is all right here.
So we just solved this, we just solved this, right?
Yes. But if your top should be,
Is it flipped?
it should be flipped, e to the
So-
x is your top one, I think.
No.
Yes,
Is it?
Green check.
yeah, but it's here.
Yes, sir. What do we do when it gets?
So,
He told me it was the top. On mine.
That's a good question. Let's talk about that. Abraham just asked an awesome question that I was hoping would eventually be asked. Abraham, what are those curves, please?
We have y equals x, y equals 5x, and y equals negative x plus 2.
So, let me tweak these just a little. So no one can claim I'm doing Abraham's work for him. God, I still hope this works. I think this is gonna work out just peachy. Let's even make that a 3. I would sketch all these out. This one's a little more complicated. So y equals 2x is aligned with slope 2. y equals 6x is a very steep line, like so. And then this one cuts across like this. So this is y equals negative x plus 3. Line of slope 1, y-intercept of 3. So check out this region. When we integrate, so this is very challenging, actually. This is probably the hardest one in the whole set, because you have to notice that top and bottom change, at least top changes. Notice that in this left half here, 6x is on top, 2x is on the bottom. But after I get past this intersection point, whatever that is, then this is on the top, and this is, and the 2x is on the bottom. So look in this one, the top curve changes halfway, not halfway, but partway through. So you have to break this one out, let's call that a point C there. So you would have to set this up as the integral from 0, which is, I think, the clear intersection of those two, top two. 0 to C, and then here I would have to do the top is 6x minus 2x dx, plus I've got a second area to find, and that's from C to wherever these two intersect, which is, I think, at x equals 1. Yeah, I think these two touch at x equals 1, so I'm gonna go from whatever that point is to 1, but the top curve now is that cut across. And then it's minus the 2x dx. Does that sound good, Abraham? Does that make sense?
Yeah.
Yeah, so a lot more recon on this one before getting in there and knocking it out.
Proud of myself for that first shot.
You what? You got it your first try.
I wanna brag about it, yeah.
Really ready for draft help.
Well done. Well done.
Which one did we decide is the top? Because I did this EDX, but it says I did it wrong.
Well, look in that window, Sophie. Which one is
I guess it's
the blue one's on top?
2x if it's in that
Uh-huh,
spot. So
yeah,
you
yeah.
do it wherever it is.
Yes. Yeah, yeah.
So then I guess everything has to flip.
But that's a pretty awesome thing,
It is, I like when
though. Yeah. It's good. You have to tell me when you're going to practice. I need a doctor who knows math.
You don't forget all of it, but it's on the
You can
pencil
treat my
there, too.
math-related ailments. How's it going here? Pretty good. So I would have to find this piece. Yes. So, yep. And you have to find that point and that way eventually, yeah. Yeah, we can do that. Okay, cool. Oh, you are. Nice. You doing here? All right. Oh, beautiful. Hey, gang.
So, I think I just have to get this area right here.
Yes, sir. Yeah.
And
So-
then to do that, I just subtract the, all the top curve minus the bottom curve,
Correct.
which is either 2x minus either.
There you go.
Okay.
That's it.
And just plug in the x values.
Yeah, you know,
Right.
do the integral and then from
Okay.
log whatever to log 2 to log 4.
Cool, thank
Yeah,
you.
you're welcome. Not so bad. Doing good here? I sensed the question.
Yeah,
Yeah.
my cheat,
What's the cheat?
just take the area of the triangle.
How would you find that? I'm curious.
Well, it's a right triangle, hypotenuse is root 8. I'm sure I can figure out this right here.
I think finding out that distance is almost as much work as, but are you sure it's a right triangle? That would be my one question to you. How do you know it's a right triangle?
-1, +1.
Okay, good job. Yeah, you're definitely right. Yeah, you can. You definitely are right.
So the triangle.
It is a right triangle. You can do your 1/2 base times height. But literally in the time that we've been discussing this, I bet you could have had it done with calculus. Do it with calculus. And then check your, I like your spirit though. That's cool.
Thank you.
I'll make sure to stay away from any right triangles from the photo. You good there, John? Is that a hand up, Sophie? Okay. It's very subtle.
Yeah, sorry. I don't know why I'm having such a hard time with this one. I tried switching the 2s and the 4s in my answer because I had
Take
the
a look.
bounds wrong, and
Yeah.
that didn't work either.
Okay, let's see. There's 2, 4. Rainbow Road, and that's. Yeah, you integrated it correctly.
Oh, that's embarrassing.
That E to the 2x is not. There's
That's
not a-
4, wait.
Nope.
No,
New.
it's just even the 2x.
Remember this rule. Remember I've told you, this is gonna happen like a billion
Oh, it's
times.
natural log.
Nope.
No. Why do I not remember how to do this?
This,
Yeah. 1 over. Yeah, it's
Yes.
1/2. Okay.
like almost every day, right?
Yeah, we
Yeah.
only did this for like 5 weeks.
I think if you just fix that, everything will fall into place. Is that you? Yes.
I was just,
Oh, okay.
I got it right.
Oh, yes, oh, yeah. Here's one for you.
No, because I just divided, I distributed. No dice, that doesn't fix it.
What?
I know.
I'm sorry.
I understand.
Alright.
I don't know, when I tried it with the
That's it's what's simplifying
yeah,
too?
it's simplified.
Okay. Alright. You tried the opposite too,
Yeah,
right?
I tried it with
Okay.
2 instead of 4. But either the 2x was the top bound and the.
Yeah, it is, for sure. Let's see, I don't know, I just wanna simplify this and see if maybe that's why it's upset, because so this is e, that's 1/2. E to the natural log 4 squared minus e to the natural log 4. So I'm gonna just like see if this is why it's upset, so it's 1/2 e to the natural log 2 squared minus e to the natural log 2. You see what I'm doing there? Like I'm just using exponent properties. And then e to the natural log of 4 is 4.
Mhm.
It's just 2 times 2.
2.
That's a 0, right? So 4.
Why did
Well,
it?
just
Oh, I guess I never 2 is 4.
try. Can you just cut and paste? Just grab that and copy it so that you don't lose
Yeah.
it. But then let's try 4.
That would just preview
Oh. I guess it just, I don't know, maybe it didn't like the.
it. It was the right answer. It just.
It didn't like the way you typed the natural logs? I don't know.
I was doing too much, I guess. I don't know.
So we're supposed to solve it all the way down, because I definitely left it like the,
It
You
worked
did,
for
and it worked
him.
for you.
yeah, like, I'll show you.
Yeah, let's see, what,
Like, I can read this
What?
the entire time.
It can, yeah.
And then
I feel like solving it.
I don't
solve
know
for this
what,
one because the
I don't know
problem
what
is
happened.
Would both these answers be correct on test?
Yeah,
that
that would be cool, yeah. I mean, on a test,
When
I would
like,
want
solve this already,
4,
get 20
ideal,
That's right.
right? That would be like the perfect
And then
one.
If I can
It would be
remember
like,
how to solve
and then
the-
this would be like
the
a
natural
point or
logs.
2 away from perfection.
Okay, I can jump with that.
Yeah, yeah,
I wouldn't have remembered how to simplify down natural log of
yeah.
4.
But can we cut and paste, let's not put it here, put it somewhere else, like on Notepad or something, just so I can see, I wanna look at.
Anything. Let me put it in.
Yeah, okay.
Business, let's see what it says. Oh, it doesn't like that.
Oh, no, those print, yeah, just open, can you just open Notepad?
Yeah, no. Ooh, that's an M.
Notepad. Yeah. Ooh, I like how it comes up with that. Ooh, that's great. I gotta get that setting on mine.
Yeah.
So.
Cause it's the same exact answer.
Man, I don't know unless like.
It simplified down to 8 over
It knew what
2.
you. Yeah, it knew
It
that.
knew that it was 4.
That's true. I don't fucking know.
Okay.
We got it.
Correct. It's
Yep,
correct.
we're fixed.
We're good now.
Yeah. All right. Yeah. I'll be right back.
So where did I mess up on here?
This is the one you were asking about. What did you find that intersection? So that's the
So
5.
for C,
right?
we got 1/3.
There's 5/3. 2 minus a third is 5/3. Okay, cool. So that definitely tracks. So we went from 0 to 5/3 up. And then this should be minus the x.
Oh,
Yes,
yeah,
here.
I looked.
Oh, okay, cool. Oh, got it.
I just wanted
see.
to like
I
put that
see.
in my brain, just like, cause I forgot to do the derivative.
Gotcha. Just a real quick note, you could have like, one less part, this would have just been 4x and made your life a little simpler.
Yeah.
And this one here too would be, easier to just pre-join them, but it's okay. Then we have, okay, so we did 5.
See,
This one, so the third,
this one.
yeah, okay. I'm just gonna check all this one first. So 5 has 90. Sweet, so what happens? The zeros die, awesome.
Just make sure.
So we've got 5/18.
Save your answer in calculator.
Switches 2. Okay. So over
Oh, that's your problem.
I forgot to
Yep,
change
yep,
those.
yep. Otherwise, it's going great. Let me get Becky and then I'll be right there. Yes, ma'am. Okay, absolutely.
Okay. So you did, that's great, that you did that, so. You got 0 as yours, huh, interesting, okay. Yeah. So you had this, here's the problem. So you had this 2, so you definitely, you're using that rule properly, but you also had a 2 in the front to begin with. So that's 2 times the 1/2 times that. So that should be 2 times a half, so it's just 1 e to the 2x, that's your problem.
Awesome.
Yeah. You're welcome. Yes.
Can you re-explain when it's like 3 different lines? Because I'm confused. So
Find the intersection in these two,
So the purple and black.
the purple and the black. Integrate, you're gonna have 2 problems then. First one's gonna be purple minus green,
Okay.
up to that, from 0 to that intersection point, whatever that turns out to be.
Mhm.
And then from that intersection point coordinate, it's gonna be black minus green all the way to 1. So you're gonna have 2 things. There's the top and there's the bottom for the first half. There's the top and there's the bottom for the second half.
Okay.
So to find x for this one, then you would have to do 2 different.
Yes, 2 different
So-
solves.
Yeah.
Yes.
Are you adding or subtracting the 2 different?
And then add the, well, I mean, like if I said, here's this area and here's this area, what would your intuition be to get the whole area?
Oh, okay.
Right? So use your intuition too. This is stuff you know.
So for
It
this-
works like reality for the most part.
For this
for
one,
once.
if I wanted to find this intersection, I would do these 2.
Yep.
And I would just separate from each other, and then the other one I wanna find is this one.
Yeah.
And so I would just do this one and this
The
one.
green and the red. Yeah.
Why do I not need to find that one? Is it just 0?
It's 0. I mean, you theoretically, you could find the intersection
Blue and
between
red.
blue and red, but
They
you'll find out it's 0. Yeah.
Sure.
Alright, yeah, what the hell's going on? This is one of the easy ones here, right?
And you likely be pretty much done after this almost, aren't you?
Almost.
Well, I think that last one's a good one.
Alright, so. Triple checking everything. So, that was 4/3, 3/4, brings a nice 3 out front. I don't know, maybe it wants you to find the 4/3 root. Do you know how to find that 4/3 root? So it's the cube root of 27 to the power 4. What's the cube root of 27? There you go, to the 4th. There you go, let's try that. Let's just try 3 times. Let's see what's happening. I don't know. It is. WebWorks it's making us walk the extra mile today, apparently.
here's your cutoff point right here.
Yep.
It's not, could you give me-
It's a problem sometimes.
Oh, is it?
Yeah,
Okay,
someone knocked
so
it
draw a
off the
straight
table.
line from that corner all the way down to the x-axis. Cool, so you've got two halves to do. This is, mark 2/5 down there right below that. So on the x-axis, let's mark 2/5. Cool.
And
So,
the other one is this one?
yeah, that's one. So you've got two regions. In this first one, from 0 to 2/5, what curve is on top?
Blue.
There you go, and from 2/5 to 1, what curve is on top?
The green.
There you
So
go.
the lines you use inside of here don't actually necessarily correlate to the intersecting points. Lines you use to like find these.
I don't understand that question.
So this is blue and red, but to
Mhm.
find this point I use blue and green, so it doesn't matter.
Yeah, there's no rhythm like that in particular. Because you also did use blue and red to get that left point in
Yes.
some ways, right? So,
Yeah, that makes sense.
yeah,
Okay, cool.
okay.
Yeah.
Yes.
So we stay on 7. Which one are we doing? Yeah, number 3.
So, you figured out which curve is which.
Yeah, this top one is x squared plus 2x plus 9.
Okay, got it. Well, so one thing is, what is the sign of your area? Is that a negative or a positive number?
That's a negative.
Does that sound like an area?
It doesn't.
It doesn't. Let's try making it positive and see what happens.
Just switching it to.
Yeah, just make both those, remove the front minus, make the other one a plus. Let's see what, oh, it's not gonna like that. Yeah, there you go. No, did you hit click submit? It didn't like it. Put, let's change that into, let's see, 225 times 3 is 675 plus 1, so let's do 676 over 3. Okay, well, let's go look somewhere else.
Yeah.
All right, so this is your work here?
Yep.
All right.
This
Okay. So, I like the way that looks. Screw those two times. Looks like you turned that into a plus. Oh, no, it is a plus. I don't know what I'm doing back on. Okay, great, so then that's plus 8. All right, see you on Wednesday, friends. This web work's due at the end of the day on Friday. What's that? Today's Wednesday.
Okay.
This Friday.
Yeah.
Sorry. Alright, so negative 2x, negative 2x, negative x squared, negative 2x, plus 8, so that all looks good. So negative x over 3 minus 6 squared plus 8x. Okay, that all looks good. Thank you. So we got negative 9 cubed minus 9 squared plus 8 plus 9. Okay, that all looks good. And this is minus, so that's a negative. And you just made the whole thing positive, positive. Okay, yeah. So it's 64 thirds. And then that's 2. So that, and then you distribute it, so you go minus, plus, and minus, okay? So this is, I guess that's right, I don't know, but that sounds right. Yeah, because that's 81 times 3, so yeah, okay. And this is, yeah, and then that's that. And I agree with all of that. And then this is 64 thirds, which is that. And this is plus 16. And then this should be minus, oh wait, there's a minus minus, right? So it's minus, so it's plus 32. So this all looks right. Would you double check the math on that?
I did.
You did?
Yeah.
Let's go back and look at your, let's just make sure, let's go from the beginning. So x squared minus 2x plus 9, and 2x squared plus 1. So I think that it's gonna be, yeah, it is, so you got it totally right. Oh, your intersections, that's what might be off. So this, I think this is now, can I see your pencil real quick? So let's check out your intersections and do it by hand. So we've got,
Oh, yeah, I was using one of those.
there you go, that'll do it.
Yep,
There you go.
so this 9 should be a 2.
That's gonna change everything.